So first of all, we need to understand some basics of SD-WAN. So SD-WAN, software defined WAN. So basically Cisco is using Viptela OS initially for the SD-WAN solution. So first of all, we need to discuss what is the difference between the traditional WAN and this software defined WAN. Let's suppose if we have multiple devices and we want to manage them in the traditional way. We can divide a device into two or three planes. Initially in the very beginning days, we were dividing into two planes. Nowadays we are dividing in three planes. One is management plane, the second one is the control plane, the third one is the data plane. So management plane, if we want to access the device for the management purposes, so we are accessing the device on the device management plane. If we are running some protocols, which protocols are establishing neighbor relationships and all those procedures, so that we can build the routing table or some other data plane uh, tables, so that we can easily start uh, communicating the devices connected to the routers. So all those protocols like routing protocol, etc., those works on the control plane. And then we have a data plane. Our interfaces belongs to the data plane. Whenever the device is connected to the routers, they want to communicate with the offline destinations, so the traffic passes to the data plane of the router. So in the second thing, what we did was we have we were having the chassis, the big devices, the routers. So in those chassis we have different options available. Like let's say the first option is uh, we have chassis. In that chassis we have a fabric cards. So those fabric cards are called as the backplane. So we connect the supervisor engines or soups on the on the backplane or that fabric cards. And in the same way, if we have different other LAN line cards, so those are available as the module. So we plug in the fabric card in the chassis so that we can be able to communicate to each other. The networks connected to those line cards. So basically, the main thing is we have to combine the solution. Let's say if we have a device, this is a single device, we can divide this device into different planes. The first one is the management plane, the second one is the control plane, and the third one is the data plane. So then this one is the control plane and data plane. Data plane is also called as forwarding plane. So let's say first of all, if we want to perform the management of the device or device management access. So for this device management, we have two options available. The first option is called as out of band management, and the second one is called as in band management. Out of band management, you have console and auxiliary. So if we are using the different ports which are not used for data communication, these are used only for the communication purposes. So these ports are called as lines. So these lines, console and auxiliary, so these are used for out of band management. Let's say if we want to access the device through the interface. Interface is the port which is used for data communication. But if we want to access some line, those lines are called as VTY, virtual telnet heap, or in short, in short we call it as virtual terminals. So VTY stands for virtual tele type actually, but to make it VTY we say virtual tele type. So these, on different devices we can have different number of ports from 0 to 4, 0 to 15, 0 to 31. So depending upon the device we can have a different number of ports. So if we need to access these logical ports or these virtual terminals, we need to get access through the interface. So interface is the port used for data communication. So line is the port used for device management. So interface is the port used for data communication. So if we are accessing a line through the interface, so we can call it as we are accessing the device. We are using the in-band management. In the same way, so this is the device management or management plane. Then the second one is the control plane. In the control plane, all the protocols running between the routers. So those can be the routing protocols, label protocol, or whatever. Based on that information, routers build their uh, routing tables or the forwarding tables. So basically, we can enable any routing protocols. We can use some label protocols so that the routers can establish a neighbor relationship, exchange the routing information, and then each router will process that routing information using a routing algorithm to calculate the best path to communicate with different destinations. So this thing is related to the control plane. The third thing is the data plane. So when we are talking about data plane interfaces. So the communication between the different interfaces is through the data plane. If we are not using the modular, so then we have some motherboard type thing which is acting as the backplane. But let's say if we want to convert this device to chassis. The benefit of the chassis, we can use multiple supervisor engine soups. So soups are managing the management plane and the control plane. So this is the second step. In the second step, we can buy a chassis. In that chassis, we can insert different modules. Some modules are used for control and management purposes. Some modules are used for data communication. So we can have basic two types of modules. The first one is the supervisor engines. In short, we call it as soup. So these soups are the control plane and management plane. If we are using in-band management, so then again we are accessing the device through the interface. So these soups, everything is, so basically we have a back plane. So this back plane has, or fabric card is used to insert different modules into the chassis. So all these supervisor engine module is the control plane and management plane. The second type of the card or module is called as line card. So line card have different number of interfaces. So when we connect these line cards into the chassis on these fabric cards or backplane, So then these are collectively forming the data plane. So if we move one step more forward, and if we are using the Nexus series switches. So when we are using the Nexus switches, so there are two types of uh, devices. One are again the modulars, and the second one are called as the fax or fabric extenders. So we will have a simple similar chassis. In that similar chassis, we are getting uh, the fabric cards. On the fabric cards, we can connect different types of uh, network cards. Let's say so in Nexus switches we have a similar chassis. In similar chassis we can have supervisor engines, we can have line cards, but there is another option available that is called as a remote line card. In these remote line cards, so basically we call them as FEX, fabric extenders. So we use Ethernet cables to connect this remote line card with the chassis. So whenever we need to do the configuration of this fabric extender, again we are using the same supervisor engine. So we are accessing them, we are accessing the same chassis, and then we are accessing the management plane of the device, and we are configuring these FEX cards or fabric extenders. So basically the same logic is used in case of the SD-WAN. In case of the SD-WAN, let's say we have a big chassis. In this big chassis, instead of supervisor engine, we are using a controller. Controller is something like a separate device. So one is for the management plane. We need one controller for the control plane, and we are gonna add a new plane which is called as orchestration plane. So these three planes are using three different controllers, three different those can be the physical devices or those can be the virtual appliances. So basically depending upon our requirement we can use physical or virtual options. Then let's say we have different service providers. So instead of those fabric cards or backplane, we are using different service providers. Let's say we have connectivity through one service provider. Let's say this is the internet service provider. We can have the connectivity. We have the connectivity through some MPLS service provider. So this is the second service provider. We can have some connectivity through some business internet, LTE, or any other option. So basically these service provider and their links. So these links and the service provider networks are acting as our SD-WAN fabric backplane. So we use, instead of the routers, we are using WAN edges. So let's say this is one WAN edge at the headquarter side, this is one second WAN edge on the headquarter side, and then we have the WAN edges at the branch offices. So let's say we have three branches. So we have three WAN edges. So all these devices are connected to different service providers. So let's say this device is connected to this one. This device is also connected to this one connected to this one. So these service providers are acting as our backplane or fabric card. Let's say this one is LTE service provider. So this one is MPLS service provider, and this one is internet service provider. So we can have global internet service provider, we can have business internet service provider. So we'll discuss all types of transports a little bit later on. So basically now you can see instead of soups we are using a controller. So this controller is called as vManage. Then we are using a second controller which is acting as the control plane, and this one is called as vSmart. Then we have another controller which is acting as the orchestration plane, and this one is called as vBond.
Oh, sorry, I did not hear the last statement. The last controller you just made.
vBond.
Bond. Okay.
Yeah, so vManage is the management plane. vSmart is the control plane. vBond. So vBond is the orchestration plane. And then these are called as WAN edges. So let's say, so the unique term is WAN edge. We can assign different names. Let's say this one is headquarter VH1. So this one is headquarter VH2. So branch 1 VH1. So branch 2 VH1. Branch 3 VH1. So basically these are the WAN edges, and we are considering them as remote line cards. We have a separate management network. So this is our management network. All these devices are connected to the management network. It can be a single switch, it can be a routed network. But this one is out of band management network. So all these devices are connected to this. management network. So this part is called as SD-WAN fabric. And this part, which is connected to the WAN edges, but it is not the part of SD-WAN fabric. This is called as the service side. On the service side, we can connect different devices. It is your choice whether you want to use a router or a layer 3 switch or switch, or it can be SD-access devices. So depending upon our requirements, we can choose the devices which can be connected here on the service side of the WAN edges. So it can be L2 switch, it can be L3 switch, router, SD-access devices. But these devices are not the part of the SD-WAN. So these are called as service side. So this one is SD-WAN fabric, this one is service side. So Cisco SD-WAN is divided into 4 planes. The first one is called as the management plane. The second one is called as the control plane. The third one is called as the orchestration plane. And the fourth one is called as the data plane. So management plane, so we manage controller. So we manage controller is acting as the management plane of SD-WAN. So then we have vSmart. So vSmart controller is as the control plane appliance or controller. So vBond is a controller used as the orchestration plane. So WAN edges are the data plane devices. So when we are talking about WAN edges, just for instance, I'm just putting some information. So WAN edges are of two types. The first one is called as V edge, and the second one is called as C edge. So V edge is the WAN edge running. Viptela OS. So this V stands for Viptela. We manage Viptela management. We smart, we bond. So it is using Cisco is using the Viptela SD-WAN solution. So they have purchased that, and then they are making the changes into the solution. So then the second one is the CS. CS is the WAN edge device. It can be a normal route WAN edge device. It can be ISR, integrated services router. It can be ASR. It can be CSR. So it can be any router running iOS XE with SD-WAN support image. So that device is called as C-Edge. So we have uh, V-edges and C-edges. Right now in the lab we will be using the V-edge. When you will be doing the preparation for your boot camp, so there you will be able to configure the C-edge as well. So basically the serial file I have, it is for V-edges. Configurations are roughly same. Only in the basic configuration, when we are using the term VPN, on C-edge we will be configuring VRF. So a little change in the basic configuration when you are accessing through the GUI, it's roughly same. So now we discuss these planes one by one. So vManage is the management plane. So according to Cisco, vManage is the NMS network management system for Cisco SD-WAN solution. So it provides a single, they call it as single pane of glass. In other words, it provides a single console or single touch point which can be used to configure the whole SD-WAN solution. So what we can do using vManage. So vManage is used for basic device configurations. So basic device configurations, after this basic device configuration, uh, let's say if we want to onboard the WAN edge onboarding. So after WAN edge and on onboarding, so when we need to configure the devices in SD-WAN, so there are two modes. One is called as CLI mode, the other one is vManage mode. So basically, when you do the configurations using the CLI, the device is in CLI mode. But when you access the device in the vManage and apply a device template on the device, it means the device is managed by vManage. You are not using CLI anymore. So to move the device from CLI mode to vManage mode, we need to define the device templates, and then we need to attach those device templates with the devices. So we can define or create the device templates uh, in the vManage. In the same way, if we want to perform the if we want to apply some policies, SD-WAN policies, so we can define these SD-WAN policies through the vManage. Other than this, if we want to do the monitoring of the SD-WAN solution, so monitoring, troubleshooting, uh, after troubleshooting, if you want to get some analytics information, so we can do all these things, monitoring, troubleshooting, verifications through the vManage. It means whatever we want to do, whatever we want to configure, we want to monitor, we want to troubleshoot, all those tasks can be performed using the vManage. So that's why we are calling it as uh, NMS, Network Management System. So if we want to do the SD-WAN automation, so we can configure the SD-WAN automation on through the vManage. So when we are talking about the vManage, so one vManage, a single vManage can manage up to 2000 vManages. So let's say whenever we are using the SD-WAN solution, and if we are using a single vManage, it means that we have a single point of failure with respect to the management purpose. So that's why it is recommended that instead of using a single vManage, we use a minimum cluster of 3 vManages. If you have a more larger SD-WAN implementation, you can keep on increasing the number of vManages, but those must be in odd numbers to maintain the quorum, or to do so that or to avoid the split architecture. So basically, we have to decide how many vManage is required in our SD-WAN deployment according to the number of vManages in our SD-WAN deployment. So a single vManage.
Saki,
Yes, please.
hello, Saki.
Yes,
Please,
please.
what's the max number of devices that the vManage can manage per time, per
One
unit?
vManage 2000. A single vManage can manage up to
Okay.
2000 vManages. So we can use a single vManage, or we can use, depending upon your implementation, let's say, but if we are using a single vManage, you have a single point of failure, or we can use a cluster of minimum 3 vManages. So if one vManage can manage 2000, it means a cluster of 3 can manage uh, 6000 vManages. So if we need more vManages, we can keep on increasing the number of vManages, but we will keep them in odd numbers. So vManage operates in two modes. Can operate uh, in a single tenant mode. So vManage can be managed in a single tenant mode or in multi-tenant mode. So it depends upon your implementation, that how we want to uh, deploy the vManage. Let's say if you are some managed service provider, so it means you have different customers, so you are managing the different solutions for. So in multi-tenant mode, you can define different tenant. Each tenant will have its own administrator password and will be able to manage those specific devices which are related to that specific organization or tenant.
Okay, sorry. Question is,
Yes, please.
what do we need to consider before the choice of the number, or whether it's a single or multi? For instance, let's assume that there will be an advantage on multi tenants because
Mhm.
of the many, management advantage. But what we define, for example, if I'm on a network that we have, let's say, 25 sites, off sites.
No, we
Okay.
are not
So
talking
do I
about
need to
sites.
configure?
We are just talking about the how many SD-WAN fabrics you want to manage through this vManage. So it is not sites.
Okay.
It is let's say different customers. Each customer can have different number of sites. So
Mm-hmm.
a single tenant mode means we are running. You have one headquarter data center, and then you have some branch offices. Let's say if there is some other organization wants to use the same vManage, so then they can we can define a separate tenant. That tenant will have its own headquarter data center and branches. So it's not related to sites. So depending upon the sites, wherever sites exist, we can place these devices into different places. So let's say, but basically each tenant will have their own control plane. So management plane means you just have to configure the device templates. You have to go for device onboarding. You have to define the SD-WAN policies. You want to monitor, troubleshoot everything. But all these things are, let's say, policies. So policies are pushed to the vSmart. vSmart is the control plane. So each tenant will have their own vSmart. So then, according to your physical location of the site, you will place the vSmarts at different locations. So we will discuss these things when we will keep on moving towards in more details.
Uh, uh, Sakib,
Yes.
this you mean to say it's a controller, and inside controller we can create multiple tenant. Is
Yes,
it
it is something
for
like
vManage?
device context or virtual context in ASA firewall, VDC, virtual device context in. So
Correct.
basically, yeah, so those contexts are acting as different devices. It means that when we are configuring single tenant, it means we are managing only one organization. So when we are using
Okay,
multi-tenant,
so
it means we are managing the SD-WAN solution for multiple organizations.
but you said one vManage, like the vManage can manage up to 2000 WAN edges only. So this is per tenant or
No, this is not per tenant.
like
This
per
is total.
device?
This
Okay,
is total. It is
I mean
not on
to
per tenant basis. So one vManage can manage up to 2000 WAN edges. So if you have multiple tenants,
okay,
you will have to divide these 2000 between those tenants.
those three tenants. Okay.
Yeah. So
How
basically,
many tenants we can create?
uh, I cannot tell you at this time because in 18.3 they have defined something. It was, I think, uh, 50 or something, but again there is no limit. You can keep on because we do not have those bigger or large SD-WAN deployments. Let's say if we are
Understood.
managing one bank. I'm just giving you an example, and that bank has 4,000
Yeah,
branches.
yeah, yeah.
So we don't need to
Mm.
configure multi-tenants. We were managing it separately. But if you have multiple very
Mm.
small organizations and you want to offer them managed service providers live contracts, so then you can keep on
Mm.
defining these tenants, and you will be able to manage them separately.
Okay. So basically, they will create the tenant and they will give the access for that particular tenant to the customer.
Yes. So each manage
Oh,
establishes the DTLS channel. So each WAN edge establishes the DTLS tunnel with only one vManage. So again, for the centralized management and control of WAN edges, we need to move the WAN edges from CLI mode to the vManage mode. So for the centralized management, centralized so for the centralized management and to apply the centralized policies, so we have to bring the WAN edges from CLI mode to vManage mode. So how we can move from the CLI mode to vManage mode? Whenever we will uh, So whenever we apply the device template or attach the device template with vManage, so it move from CLI mode to vManage mode. There are some other tasks. Let's say if you want to perform in-service software upgrade, ISSU, if you want to take the backup and or you want to restore the configurations, so backup and restore. So basically, all these functions can be managed through the vManage. Then we have vSmart. So vSmart is a control plane. Control plane controller of SD-WAN. So basically, when we are talking about vSmart, so vSmart is the device which is used as the control plane controller or control plane appliance. But actually, Cisco developed an advanced routing protocol. So now Cisco call EIGRP, BGP, OSPF as the traditional or legacy routing protocols. So Cisco developed an advanced routing protocol, OMP, overlay management protocol. So this OMP is the control plane. Protocol of SD-WAN. So vSmart is the controller appliance which is acting as the control plane. But actually this OMP, overlay management protocol, so it is an advanced routing protocol. So this is acting as the control plane protocol of SD-WAN solution. So each WAN edge uh, establishes the DTLS connection with minimum 1 vSmart, and the second thing is or maximum 2 vSmarts. So each WAN edge establishes the DTLS tunnel with at least 1 vSmart or maximum 2 vSmarts. So when it establishes this DTLS tunnel, on this DTLS tunnel, the WAN edge and the vSmart, so they establishes the OMP neighbor relationship. So within the DTLS tunnel, OMP neighbor relationships are established between the vSmart and WAN edges and vSmart to vSmart. If you have multiple vSmart, So those vSmart will establish the OMP enable relationship between them as well. So vSmart and WAN edges, vSmart and vSmart. So these OMP enable relationships are established within the DTLS tunnels. So when we are talking about OMP, just to understand the basic behavior of OMP. So OMP is something like it is the combination of IBGP route reflector and NHRP, or somehow you can compare it with Lisp. Basically, we are not having the control plane node or those things, so that's why we consider it something more like NHRP than Lisp. NHRP and Lisp both provides the mapping of public and private IP addresses to reach some specific device. So OMP is combination of IBGP route reflector and NHRP, next hop resolution protocol. So when OMP enable relationship is established between WAN edge and the vSmart. So basically vSmart is not in the traffic path. So vSmart is only the controller which is used to provide the control plane information to the WAN edges. So basically when WAN edges are establishes the OMP enable relationship with the vSmart, so they advertise their connected static and OSPF internal routes by default. So each WAN edge advertises.
WAN edge is nothing but the device which is sitting at a remote location or branch location, right?
Yes, WAN edge is the you are replacing routers with WAN edges.
Ah, understand.
Your remote line card.
Yeah, understand.
So each WAN edge advertise its connected, static, and OSPF internal routes into OMP. So all these routes are advertised to vSmart. So when all those routes are advertised to vSmart, so vSmart is acting as the route reflector. So it advertises all those routes to all other WAN edges. So it means that all the WAN edges will receive the routes of other WAN edges through the vSmart. So vSmart advertises the routes learned from WAN edges to all WAN edges. So in other words, each WAN edge gets the routes to reach all networks connected to other WAN edges. OSPF external and BGP routes can be advertised into OMP. So these are not advertised by default. So we need to configure them if we want to advertise these routes into BGP. So basically, when WAN edges gets the routes, and instead of RLOC, we use a term which is called as TLOC, transport location. So route is the network or prefix. TLOC is the WAN edge through which it is reachable. So when WAN edges gets the routes and TLOC routes, transport location routes of other WAN edges.
Repeat that last line about TLOC.
TLOC transport location, in Lisp we have used the term RLOC, route location. Let's say this prefix is reachable through this router. Yeah, so here we use TLOC transport location. So that,
Okay.
yeah, so basically when
So
we
that information is provided by VSmart to the
vSmart, yeah. So
other router,
basically,
which is
let's say,
okay.
just to establish the understanding, so we have, these are headquarter WAN edges and these are branch WAN edges. So we have vSmart. So all these devices are connected to the transport VPN. Transport VPN is underlay. So this is our underlay. Right now we are, let's say we are using a single service provider. So all these sites, all these WAN edges are connected to the same service provider. So now what will happen is, first of all, they establish the DTLS tunnels. So this is the DTLS tunnel. Over this DTLS tunnel, these devices will establish the OMP neighbor relationship. So these are DTLS tunnels.
Sorry. Okay, so the DTLS, same DTLS tunnel which was used by vManage
No, that is a separate
have all
one.
these devices.
Basically, vManage is a separate device.
Okay.
So each manage establish one DTLS
Okay.
tunnel with vManage, one DTLS tunnel with vSmart.
Okay. Okay.
So this is the DTLS tunnel. Over this DTLS tunnel, these devices will establish the OMP neighbor relationship. So over the DTLS tunnel, these devices will establish the OMP neighbor relationship. So this device is your vSmart. And these are your WAN edges. So let's say we have a network 10.1.1.0/24. So this is the prefix, this is the route, and this device, so this device is using a system IP 10.1.1.15. 10.1.1.15. So this device is 10.1.1.16. So we said system IP is something like router ID 10.1.2.15. 10.1.3.15. 10.1.4.15. So basically these are the system IPs. So now let's say the same network 10.110 is reachable because we have redundant devices. So here we have 10.2.1.0/24. Ten dot 3.1.0/24. 4.1.0/24. So these are connected networks. So these connected networks are automatically advertised into OMP. So vSmart will get the information that 10.1.1.0/24 reachable through 10.1.1.15. Let's say this is the best route. So let me make this one 4, 3, 2. 2, 3, 4. So these are the routes learned from these different WAN edges. So now what it will do is, it will advertise these routes to all WAN edges. But when it will receive 10.110, so it is learned from the same site. So it will ignore this one and keep these routes 10.2.1, 10.3.1, 10.4.1. In the same way, when all these routes are advertised here, so this one will ignore 10.2.1.0 and keep rest of the 3. So it is directly connected. So we are not going to use OMP over the directly connected one. So now this is the route or prefix, and this one is TLOC. How to reach this prefix? So these two types of routes, the prefix routes and TLOC routes. So these are advertised. So TLOC is acting as the next hop in BGP. So now all these devices get the routes and TLOCs from the vSmart. And when they get this information from the vSmart, so now they will try to establish BFD connection. So it gets this information 10.1.1.15, 1.3.15, 1.4.15. So first of all, it will establish the BFD connection with this one. Then it will try to establish a BFD connection with this device, and then this one. In the same way, all these devices will try to establish the BFD connections with all the TLOCs received from the vSmart. So when they get they successfully establish the BFD connection. So then they proceed towards the establishing the IPsec tunnels. So now let's say our BFD connections are established. So when BFD connections are established, so overlay tunnels, IPsec tunnels are established then. So when these IPsec tunnels are established between them, it means we have our transport channel or data plane transport channel is established between these devices. And now we can communicate using these overlay tunnels. So this black.
So, Satyam, I have one question.
Yes, please.
Suppose here you are showing only 5 routers. Okay, now practical scenario will have suppose 200 routers. So we'll have, like, if you will multiply, one device can have how many IPsec tunnel at a time?
N into n minus 1 divided by 2.
n minus
n into n
n
minus
divided
1
by.
divided by 2. So,
So that
that's why
much tunnel it will
it is basically,
be like
if by default SD-WAN topology is full mesh. So by default SD-WAN topology is full mesh. So if we want to change it to hub and spoke, so we need to apply the policy. So we need to apply centralized policy.
Said, you have
Yes,
given
please.
up on your solution.
Sorry? Can you repeat your question, please?
you are not audible.
You can type the type the question in chat. So basically, by default, SD-WAN topology is full mesh. We can convert it into hub and spoke or some custom control topology, whatever we would like. Let's say. Okay, so basically this problem is at your end. So I think other people can hear me clearly. If anyone else is also getting the problem, then I can look for some internet connection or something. Okay. So by default, SD-WAN topology is full mesh. Okay. So, but we can convert it into hub and spoke and custom control. So, okay, custom control means, let's say we want to allow communication between some branches and headquarter, and or basically the thing is we can have different service VPNs. Let's say you have employees network, you have guest network, you have IoT network, you can have different service VPNs. For different service VPNs, we can define different topologies. So it is not necessary that for all the VPNs we are using the same topology. But the basic idea is so that you can understand how the communication is happening between these WAN edges. So first of all these devices establish the DTLS tunnel with the vSmart. Over the DTLS tunnel, they will establish the OMP neighbor relationship. Over using OMP neighbor relationship, they advertise their networks to the vSmart. vSmart is acting as the route reflector. So whatever it will receive, it will advertise it to all other WAN edges. So it is advertising three types of routes. The first type of the route is V route or OMP route, which is this prefix. The second one is called as the TLOC route, transport location route. The third one is the service route. So we will discuss these in the control plane. So when it will advertise the prefix and TLOCs. So whatever the TLOC routes are received, so WAN edges tries to establish the BFD connection with those TLOCs. If BFD connection is successful, then they proceed towards the IPsec connection. So IPsec connection information is also carried over the DTLS tunnel through the vSmart. So when the IPsec connections are established, so now we can communicate the service side or service VPNs traffic using this overlay network. This IPsec tunnels are the overlay, and this black network, the service provider, that is the underlay. So one vSmart can establish 5400 DTLS tunnels.
So underlay is nothing but the DTLS tunnel only, right?
No, underlay is your connection with the service provider. In the underlay, you can use BGP, you can use OSPF, or you can just use the static routes, default route.
Just to reach vSmart.
Yes,
Correct.
yes. So basically, these TLOCs must have to be reachable through the underlay. So one vSmart can establish up to 5400 Uh, DTLS tunnels.
Okay.
Yes,
Sorry,
please.
what's the DTLS tunnel? Is it the connection to the vSmart and the VH?
Yes, basically there is one is TLS tunnel, so the other one is DTLS tunnel. DTLS tunnel is a tunnel based on the basically you have two protocols: transmission control protocol, user datagram protocol. So this is a tunnel, secure tunnel over UDP, user datagram protocol. But it is we use the digital certificates. So authentication is performed using the digital certificates. The encryption keys, hashing algorithm keys, those are generated and exchanged through these digital certificates. And when they successfully can perform the encrypted and secure communication between them, we say they have established a DTLS tunnel. It is not something a separate pipe. It is just a secure connection. So in old days we were using SSL. SSL is over TCP. So DTLS is over the UDP. So we can one vSmart can establish up to 5400 DTLS tunnels. We can use maximum of 20 vSmarts in one SD-WAN deployment. So if you are using multi-tenant, so each tenant will have their own vSmarts. So vSmart cannot be shared between the tenants. So orchestration plane. So VBond is the orchestration plane of SD-WAN. So when a WAN edge completes its boot process, so when a WAN edge completes boot process, so it tries to join the SD-WAN fabric. So first of all, it connects with the VBond. So basically, right now because we have performed the manual configuration, so I'm explaining it in that context. So in the next step, when we will define, we are discussing the device onboarding process. So we will then at that time we will use the Cisco plug and play and zero touch provisioning. So those processes. But right now you suppose that we have provide all basic information or configuration manually, like we did in our lab. So when a WAN edge so when a WAN edge completes its boot process, so it attempts to join the SD-WAN fabric. So first of all, it establishes a DTLS tunnel with vBond. So both devices vBond and WAN edge mutually authenticates each other on successful authentication. So vBond provides the vManage and vSmart connectivity information. So WAN Edge establishes the DTLS tunnel So WAN Edge establishes the DTLS tunnel with vManage and vSmart. And tear down the DTLS tunnel with vBond. So vBond is only to perform the authentication, basic authentication, whether this device can join the SD-WAN fabric or not. So it tear down or terminates. So basically when WAN Edge establishes the DTLS tunnel with vManage and vSmart, so tear down, or let's use terminate. Terminates the DTLS tunnel with vBond. If we have multiple vBonds, then we can use DNS load balancing. Let's say if you have a very large deployment and you are using multiple vBonds, then we can use DNS round robin load balancing. By default, DNS provides round robin load balancing. To divide the load between vBonds. So after this, we have already discussed that we have two types of WAN edges. So WAN edges are the data plane. Data plane devices of SD-WAN. So we have already discussed we have two types of WAN edges, V edge and C edge. VPN. So VPN, so this term is used for VRF in SD-WAN. So this term is used for VRF in SD-WAN. So basically when we want to connect one VRF on one router on with the VRF on the other router. So we need to use some number so that we can map these VRFs. To map the same VRF on different WAN edges, we need to use a number, so which is called as VPN ID. So VPN is the logical mapping of the same VRF on different WAN edges. So VPN ID is a 16 bits value, and the range is from 0 to 65535. So VPN 0 is the transport VPN or underlay of SD-WAN. VPN 512 is the management VPN. So we can consider it as out of band management. Then VPN 1 to 511 and 513 to 65535 are the service VPNs. So this VPN number is carried in the IPsec tunnel as the label that this traffic belongs to this. Let's say if you are using the if you are using multiple VLANs on your switch network, so you use VLAN ID. So those VLAN IDs are carried in 802.1q header, that this traffic belongs to this one. In the same way, here we use a label, and that label carries the VPN ID, that this traffic belongs to this VPN. Or the labels can be assigned to VPNs.
These VPNs are nothing but the tunnels between WAN edges and V-bond, right?
No, basically, let's say this is the IPsec tunnel, this green one,
Okay.
and we have three VRFs on this router. So
Okay.
the first VRF is for employees, the other is for IoT, the third one is for guests. So let's say we
Okay,
do not
that
want to
VPN.
carry the guest over the SD-WAN fabric. Maybe for the guest we can configure direct internet access. But we want to carry
Correct.
the IoT and employees traffic towards the data center. So those both are carried within the same IPsec tunnel, but we have to, yes, you can configure the route leaking. So we'll configure in one lab. So basically on data center we'll be using some other VPN, and for the customers or the users we will have different VPNs. So if we want to provide access to different users in different departments over the data center, so then we have to configure the route leaking. So then the same IPsec tunnel can carry the traffic for different VRFs or different VPNs. We don't need to establish separate IPsec tunnels for each VPN. 100.38. Let's start one VH. If we will have time, we will start others and okay, let me go to the router first. On the router, we have to no shutdown interfaces. So interface range.
Our lab V-bond has same image of uh, V V-bond, right? V-bond has image of
VH.
VH. Yeah.
So we go to configurations, devices, WAN edge list. So basically, I have to upload the WAN edge list. I have a serial file. I will use this upload WAN edge list, and then I will browse to choose the file. On the desktop, I have a folder serial file, and I will select the serial file. And then we'll select validate the uploaded VH list and send to the controllers. So we have to wait so that those controller becomes available. Otherwise, we will have to uh, upload this VH list again and again. So let's go to dashboard to verify.
How you got this list? That serial number list?
You can generate this accessing the uh, Cisco plug and play center. So basically, there is Cisco software center or something. So I will share the process. So but you need some
Okay,
company email, so you cannot use the public email.
understood.
So vSmart is ready. vBond is also ready. So now these are up. So we go to configuration, devices, upload manage list, serial file. Okay.
Sorry, which file is that to be uploaded?
You have to generate this file from the Cisco Software Center using
Okay.
your email address.
Ah,
In some of the, let's say maybe on next Monday or something, I will show you how we can generate this file.
okay.
So now it is
Okay, so
pushing.
this file will have the serial number of my devices, right?
Yes, it is.
Okay.
So push BH list, it is successful. So we go back to devices. So you have these 4 serial numbers. It means we can add 4 devices in our SD-WAN. So right now there is no any device added. So what we'll do is we'll click on these 3 dots and then we will say generate bootstrap configuration. Click on OK. But now you can see we have UUID and OTP. So we need these 2 types of information to onboard the WAN edge on SD-WAN fabric. So let me check whether our WAN edge has completed its boot process. Okay. So here we will use a command request vh cloud activate chassis number, and now I will copy this UUID and paste, and then token is your OTP. So we'll copy this OTP and hit enter. Show control local properties. So we have to wait for this token value shown as invalid. This is one-time password. If it is used, then it will show here invalid. Invalid means your device has joined the SD-WAN fabric. So it will show us here as well. So let's give it some time. We will use this refresh button and you can see this device is onboarded. Headquarter VH1 10.1115. So now I will access some other WAN edge. Let's start this one. And we go to the branch 1 VH1. Yes, it is. So we have already completed the initial configurations. So you can call it as something like manual bootstrap. So tomorrow we will discuss the zero touch provisioning process. So admin. So we'll say request VH cloud activate chassis number. So we'll go to vmanage. We'll click on 3 dots on the second serial number. Click on generate bootstrap configuration, cloud init, OK. And then we will select this UUID, copy and access the WAN edge, paste, then use the keyword token, copy the OTP, and paste the OTP on the WAN edge. So click on refresh. So this device is also onboarded. So now we'll click on the, let's access this, start the fourth one.
Sakib,
Yes, please.
I have one question.
Yes.
Like the serial number which is there in vmanage
Yes.
should match with the vmanage of branch office, right?
No, it is just
Or
a
it is
license.
auto generated.
It is just a license.
Okay. Because there it is showing as a chassis number. So
Yeah, so basically
I
the thing
thought
is,
like,
we have these devices are virtual devices. So we generate the file, it
mhm.
gives us the serial number. We will configure those serial numbers on the devices. So then when these devices will try to establish the VBORD, so VBORD will have the same serial file list, serial file. So when it matches, so VBORD and WAN edges authenticate to each other. We have already, if you remember, we have installed the certification authority certificate on all these WAN edges. So
Yeah,
they have
yeah.
the certificate from the same certification authority. So that will be signed, and after successful authentication, they join the SD-WAN fabric. So admin is the username password. So now we will say request.
And suppose if we have a physical device as a V edge, then in that case,
So basically that device will have the serial, you will have to do the same process. So then when
but
you will
here,
generate the serial file, that serial file will contain the chassis number of that device.
yes, that was okay.
Yeah.
So there is some two different process, one for virtual device, one for physical device.
No, basically when you buy the solution from Cisco, they will give you the serial number of the devices which they are handing over to you.
Okay. And suppose if V-bond is getting, exchanged or something like it went faulty, so we will have new device.
Yeah, so
In that
basically
case, they will again give you
you
the
will just,
serial number file.
yeah, so you will click here on the controllers and it will show you
Okay.
send the WAN edge list to the controllers. You will just select that option and the WAN edge list is forwarded to the vBond.
Add controller.
Hmm. You will add the controller and send you will get an option here. Push the V edge list to the
Okay.
devices, to the controllers.
Okay.
So now we have to add the third and fourth one. So we click on three dots on this third serial number. So generate bootstrap configuration. Okay. Copy the cache number or UUID. And then token. Copy the OTP. So now we access the last one. Okay, it is still initializing. So three devices are onboarded, but they are in CLI mode. So tomorrow we will discuss device onboarding, ZTPs, and Cisco plug and play. After that, we will discuss the templates. We will configure some templates and attach those templates to these devices. Generate bootstrap configuration, okay. So now we have to copy this UUID. Yes, it is. These serial numbers are taken from the serial file I have uploaded.
Yes, Sakib, what is the second command? After the request VH cloud activates, then there is
Second
another
number,
command you use to show control.
show control local properties.
Okay, look up.
Let's say if we go to this one and we use show control local properties. So it will show you that the chassis number and serial number and token becomes invalid. So if we click on space, then it will show you the number of connections established. 200.1.3.15, this is the number. So basically when we will apply the templates, after that I will show you all these things. Anyway, this is the last step we have to do today, that we have to activate this device. So Yes, basically the token is one-time password. So when it is used, it cannot be used again.
So you have to generate the file again.
This file, serial number file. So you go to Cisco Software Center, then go to Cisco Plug and Play. There you have the option to generate this file. I will show you the process. Basically, I have to generate a new one. So which will have the serial number for CHs as well. So I will show you the whole process. Okay, now this device is ready. We will just go to admin, and then we will say request VH Cloud, activate chassis number, and we go to vmanage. We copy this. Okay, how long the token will be valid? So basically, here when we generate this token, so it remain valid until it is used for the first time. So whenever you will regenerate, you will regenerate the same token. It is actually some certificate signing request, and it remain valid equal to the validity of the certificate authority certificate. It can be 1 year, 2 year, whatever you have defined. So if let's say you have generated and you haven't used it, so then you can regenerate it, but it will regenerate the same value again. It will not give you the new value. It is something like certificate signing request. So signed certificate is issued to the VH Cloud. So it is something like CSR. We are generating the CSR when we are using these commands. Request VH Cloud activate chassis number. So we are giving this one and the password. It is something like this device is requesting the certificate signing request. So when the certificate signing request is is signed by the certification authority and it is installed, then it is converted to the digital certificate. So now all these devices are onboarded. So we will keep up to date today. In the next class, we will start working on